Hello, welcome to CP Addict, and in this video I'll be sharing with you guys this new problem of August LeetCoding challenge. This problem is called Reorder list, and in this problem we are given a linked list which is having n plus 1 nodes L0, L1, L2 and up till Ln, and we have to order this list in such a way that it becomes like this: L0, Ln, L1, Ln minus 1. So you can notice that the first node should come first, then the last, and then the second, then second last, and then third last, and so on and so forth. And it is also written that we cannot modify the values of list node. We have to actually physically shift the nodes. Like the next pointer of L0 is right now pointing to L1. We have to somehow point it to Ln, and we have to do it in such a way that we do not lose track of few nodes. So the thing about linked list is that if we modify the next pointer of L0 to Ln, so if L0 is now pointing to Ln, then we may lose the hold of this part of the list. Like we can only reach L1 through L0, right? We cannot have any other way to reach L1 or L2 or L3. We can reach to a node from its previous node itself, and we also need to have constant space in this problem, I guess. So how we can do this? Pause this video and think for a second how we can do this problem. So in this problem you can notice that the list is nothing but first node, then last, then second last. So we can say that if we have somehow the reverse of linked list, the second half of the list is reversed, then we don't need to do anything but just alternating the elements of the both lists. Like if we have L0, L1 to Ln by 2, and second list is Ln by 2 plus 1, Ln by 2 plus 2, and we reverse this second half, like the Ln becomes the head of the second list, then we just need to alternate the positions of the list. So how I did this problem was, first find the middle element of this list. If there are odd elements like this list, the middle element will be 2, and if there are even elements, then the middle element will be 4, the n by 2th element. So let's see the code. So we have written this code of get mid. So we initialize the slow pointer and fast pointer with the head of the node, and then we increment slow by 1 and fast by 2 pointers. So at the end, the slow pointer will be pointing to the mid of the list and the last pointer will be at the end. And we have to add this extra this extra condition so as to make sure that the list does not have the more elements than required. Like we don't need the middle element to be 2 in this case. We need to stop it at 4. So if slow is at 1 and fast is at 1, we can just move slow by 1 and fast by 2. Then fast will reach by at 2. Okay, so if we apply the same thing again, the fast will reach at the null, but slow will be reaching at 2. So we don't want that to happen. So this is the second condition which prevents it to go to the next element, and then we return slow. So this is nothing but just a simple get mid function, and after that we need to reverse the second part. So we have written the reverse code, reverse function, and in this we just maintain 3 pointers, like the current pointer, the previous pointer, and the next pointer, and at each point we just make sure that all the pointers point to the correct direction. And after that, the previous element that will be pointing to the last node, because at the end current will be pointing to null, the previous will be pointing to the last non-null node, and we need to return this previous pointer. And after that, this is the main function which we had to write. So what I'm doing is, if the list is containing only 0 or 1 element, we need not do anything. So one thing you can note is that we cannot return anything. We are not returning the list node. We are not returning the pointer to the head. Because we have to modify the pointers itself. So we first get the mid, and the second head will be the reverse of the mid of next. So if this is the list, we get mid at 4, and then we want the reverse of this second part. So the second part gets reversed and it will be returning the pointer to 3. And after that, we just maintain a count. If count is even, the next pointer is going to be from the head 1, and if it is odd, it is going to be from the head 2. And after that, if there is any extra node left, we are just appending it at the end of the list. And since we did not return anything, we just end it here. So you can see that we have made the head equals to the pointer which needs to be the new head, right? So head will not change because it is still pointing to the first node. So that's all for this video. I hope you liked this one. We'll be back with the another video. So please like and subscribe our channel. Thanks. Bye.